Okay guys, let's take a look at today's lesson. What we're going to be doing today is one step closer to proofs. We simplified trig expressions than the last lesson. Today what we're going to be doing is transforming them. We actually have a goal. We have a place that we want to go. We're going to take this portion, this trig expression, and we're going to turn it into this. So I think this is a little bit easier than the simplifying because we actually know where we want to be. We know what our goal is. We want, in this first case, to get to sine, just sine x. All right, so let's go ahead and start. So we look at this expression here on the left, and the first thing that jumps out at me is this pi over 2 minus x. It's like this big neon sign. To me, it's like, wow. This side doesn't have cofunctions, so I need to take that out. So that would be the very first thing that I would do, is I would take the cofunction property and use that property. So we know the cofunction for sine is cosine. And of course my reason is cofunction property. Okay, so that would be the first thing that I would want to do. So then we look and see what we have left. We have cosine tangent. That's a little bit better than we started, but we really want to get to sine. And I don't have sine here at all. But I know that tangent has sine inside it, right? It's a quotient property, so I'm going to do quotient property next. So quotient for tangent is sine over cosine, and that will be my quotient property. So now I think that we can see if we simplify, we cross out those two cosines, we are where we want to be, which is at sine, just regular sine x. So we cross these out and we're left with sine x, which I call simplify. Some people call it cancel or other kinds of things, but I just call it simplify. And now we are where we wanted to be. Yes. Oh yeah, abbreviations are good. Yeah, abbreviations are fine. QUOT period, simplify, cofunction. Yeah, you can abbreviate. And so it's going to be important for us to keep in mind that we only do a maximum of 2 steps per line. There has to be a reason for everything that you do. Every single thing that you do. There is no jumping from A to B because of, I don't know, I've had students write the reason magic on their proof. Sorry. There's no reason magic. That's just not a thing. So let's not do that, okay? We need an actual legitimate thing. And you can gain points. You can gain points for doing correct steps. So as long as you're doing correct steps, you need to feel good about that. Okay, this is a correct step. I'm going to get more points. The more correct steps, the more correct, points. So we just want to do correct steps, not crazy, weird steps. So that's our first one. So let's look at the second one. On this one, I see that even odd property is kind of glaring at me. I want to deal with it. I need to get to cosine squared. I don't have a cosine over here at all, but I think we can get to one. So the first thing I'm going to do is deal with that even odd property. I'm going to split this up. We talked about this just a few minutes ago, in that I can't apply even odd property in its squared form. It won't come out correctly. So the first thing I'm going to do is to separate them, which is really an exponent rule. I have an exponent rule that allows me to write them together as squared or separate. Now I'm going to do the even odd property. So we know sine is odd, so negative sine x times negative sine x. And that's the even odd. Okay. So then let's just clean it up a bit. I have negative sine times negative sine, which is a positive sine squared. So I have sine squared over tangent squared. And I just multiplied. Okay, so let's just go back and see what we need. We need to have a cosine. So there's a couple of ways I can get there. I can create a complex fraction here. I can turn tangent squared into sine over cosine and create a complex fraction, or I could do a reciprocal property with tangent, 1 over tangent is cotangent. Really, again, this is kind of a choice for you. You don't all have to do the same thing. We just all need to get to the same place. I went ahead and did reciprocal property just to get rid of the fraction. So we have sine squared, cotangent squared, and that is reciprocal property. Okay, so now I still need my cosine, but we know there's a cosine inside of that cotangent, right? So if I take that cotangent and I do a quotient property, so we have sine squared I'm not messing with. Cotangent is cosine squared over sine squared. Now, is it okay for me to split cotangent squared into cosine squared over sine squared? Is that okay? Remember, because we know that's not the real property. The real property is cotangent is cosine over sine. As long as if I had cotangent times cotangent, and I did cosine over sine, that would create this, right? As long as we think through the process to see would it actually create this, and it would, we would be fine. Unlike here, that wouldn't have worked. Okay, so we have the quotient property, and now if we just simplify, right? We cross out the sine squareds, make those go away. We're left with cosine squared, and so that would be simplification or cancel, just kind of whatever you want to call it. Okay, are we okay with that? Okay, our last one. So we have a fraction. Our goal does not have a fraction. We have subtraction. Our goal does not have subtraction. Both of those things we have to get rid of. We have to think about how I'm going to get rid of the subtraction, how I'm going to get rid of the fraction. Okay, so I'm going to work on the subtraction first because 1 minus cosine squared, hopefully by now that should be like a neon sign to you, I'm hoping, right? That's Pythagorean theorem. 1 minus cosine squared is sine squared. So I'm going to go ahead and get rid of the subtraction first. So let's turn that to sine squared over tangent, and that is Pythag. Okay, great. I don't have subtraction anymore, but I still have a fraction. So I have some options. I could create a complex fraction and make it crazy looking, or I could, I'm going to do a reciprocal probably and just get rid of the fraction first. Do I have to? No. Like I said, there's plenty of ways to go. I'm just going to get rid of that fraction because this doesn't have a fraction. So I have sine squared, and then 1 over tangent is cotangent, and that would be reciprocal. Now notice I have one of these signs I need, right? I don't need the other one. So some students find it clearer to split these up into sine times sine so that they can work with it like that. Do you have to? No. I'm just saying some students find that to be a little bit more comforting. We know we want to keep one of the signs back. The other sign something needs to happen with it. And it looks like probably we don't have a cotangent in here, so I need to do something with the cotangent, right? What if we did a quotient rule? Quotient rule with cotangent. So we have sine, and then we have cotangent is cosine over sine. That's my quotient rule. And then I think we can see that one of those signs will cancel with this sign, and I'll be left with sine times cosine, which is simplify or cancel. Okay, so we achieved our goal. Now we know where we're going and know what kind of steps we need to do to get there. Think about it. If you have a fraction, if you're given a fraction and your answer is not a fraction, then you need to think about how am I going to get rid of the fraction and those kinds of things. Okay, if I have subtraction and I don't in my answer, how am I going to get rid of the subtraction? Those are the questions that we have to ask ourselves when we're transforming. We're going to a particular place, not just anywhere we want, but we're going to somewhere particular. Okay, any questions on that?